Today we're going to talk about how to divide rational expressions. In my last video, we multiplied rational expressions. You're going to see a lot of similarities between these two methods. The first thing that you might notice is that the instructions are exactly the same. We're going to simplify and we're going to state the excluded values. Steps 1 and 2 will be exactly the same. Step 1 was to factor everything that could be factored. In this first example, all of my terms are monomials, so no factoring is needed. Step 2 is to state the excluded values. We do this by focusing on the denominators. We only look at the denominators that have a variable in them. So we're going to take this denominator, 4k to the fourth, and we'll set it not equal to 0. We do not want our denominator to equal 0 because a fraction with 0 in the denominator is undefined. When we solve this, I'll divide by 4, which gives me k to the fourth not equal to 0, and then I'll take the fourth root of both sides, so k cannot equal 0. This will be my only excluded value for this problem. Now that I have stated my excluded value, I'm going to go back to the original problem. Step 3 in multiplication would be to cancel, but this is a division problem, and we can't divide fractions just like this. We have to change it to a multiplication problem, and the way we do this is we take the second fraction and we use its reciprocal. We flip it. Sometimes you'll hear catchy phrases like keep, change, flip, but I want you to realize that the flip means the reciprocal. Anything in the denominator comes to the numerator, and anything in the numerator goes to the denominator. It's a good idea to once again check for those excluded values, because sometimes when you do the flip, you bring a new excluded value to the denominator. In this case, both of these are just constants, no variables, so I do not have any additional excluded values. It's time to cancel. Anything in the numerator can cancel with anything in the denominator. It might cancel entirely, like this 8 with this 8. Or, in the case of 4 and 10, they don't cancel entirely, but they reduce. Both are divisible by 2. After you have canceled or reduced everything that can be canceled or reduced, I want you to then take all the remaining numbers or variables in the numerator and multiply them together. I've got 1 times 2 times k to the fourth. That gives me 2k to the fourth. In the denominator, the only thing I have left is a 5. I always encourage you to double check your final answer. This is a great place to catch things that might need to be simplified further. In this case, I don't have anything else to simplify, so I'll go ahead and box my final answer. Number 2 is an example that also includes all monomials. So we'll start it just like we did number 1. The first step would be to factor everything, but no factoring is needed. So now I'll state my excluded values. In this case, I've got an 8x and a 5x in the denominator. Both of them are going to give me the same excluded value, which is 0. There's no need to write it down twice. So this is my excluded value. Now it's time to change this to a multiplication problem by using the reciprocal of the second fraction. Once you write your reciprocal, double check this new denominator number. Does it add an additional excluded value? 9x squared is going to also give me an excluded value of 0. So again, there's no need to write anything that just is repetitious. It's time to cancel. Look for anything in the numerator that could cancel with something in the denominator. 2 will divide into 2 one time and into 8 4 times. 5 and 9 cannot reduce, and 5 and 4 cannot reduce. So we're done with our numbers. Let's look at the x's. I have a single x here that can cancel with the x on top. Now I have this x squared. Remember, the exponent tells me how many x's I have. This would be 2, x times x. This is x cubed, meaning I have 3 x's here. I can take these 2 x's and cancel out 2 of these, and it will leave 1 remaining x. Now that I've canceled or reduced everything that I can cancel or reduce, I will multiply all numbers or variables left in the numerator together. That will give me 5x. I'll do the same with the denominator. 4 times 9 is 36. Double check to see if I missed anything that could have simplified further. And if not, I'll go ahead and circle or box my answer. In number 3, we add some binomials. And so now we'll get to see some factoring. Remember, when you look at a binomial, you have 3 questions to ask. The first question is, do these 2 terms have something in common? No. The second question is, are these 2 terms the difference of 2 perfect squares? Nope. And then the third is, is this the difference or sum of 2 perfect cubes? No. If you answer no to all 3, I want you to put parentheses around that binomial. The reason we do this is a reminder. I can only cancel a binomial with an identical binomial. Same thing for n plus 7. I'm going to go through the 3 questions. The answer to all 3 questions is no, so I'll put parentheses around n plus 7. Now, 7n squared. This is a monomial. Monomials can't be factored. They're already in simplest form. Parentheses are not needed because I can cancel the individual parts of a monomial. 4n cubed plus 28n squared. Do these 2 terms have something in common? Yes, they're both divisible by 4n squared. When I do that, I'm left with n plus 7. Now it's time to state the excluded values. Since I have n plus 7 down twice, there's no need to solve it 2 times. Let's just do it once. The excluded value for n plus 7 will be that n cannot equal negative 7. Now I'll do the 4n squared. The excluded value for this will be that n cannot equal 0. It's time to multiply. So I will change my problem to a multiplication, and I will use the reciprocal. Everything in the denominator will come to the numerator, and everything in the numerator will go to the denominator. At this point, double check your new denominator to see if it adds any new excluded values. This one does not, so I don't need to go through that process. Let's look for things that cancel. n plus 7 will cancel with n plus 7. There's nothing to cancel with the n plus 6, so let's focus on these 2 monomials. Remember, you can cancel the individual parts of a monomial. The 4 and 7 do not cancel or reduce, but the n squared will cancel with the n squared. Now let's multiply anything that remains in the numerator together. I've got a 4, and I have n plus 6. As far as the denominator, the only thing remaining is the 7. You can leave this as your final answer, or if you choose, you could distribute your 4. Just remember, if you do the distribution, you cannot cancel further. A binomial is not going to cancel with a monomial. In number 4, we have some trinomials. In the factoring process, when you have trinomials, you're going to break it down into 2 parentheses. The v squared splits into v times v. As far as the final number, you want to ask yourself, can I think of two numbers that would multiply to a -6 that will ultimately subtract and give me a -1? If they multiply to a -6, I know that they have opposite signs. And when they have opposite signs, I subtract and keep the sign of the larger number. Have you thought of what they are? 2 and 3. So which one gets which sign? The larger term always matches the sign of the middle number. So -3 and +2. Now let's look at v minus 3. Let's go through our 3 questions. Do they have something in common? Nope. Difference of 2 squares? Nope. Difference or sum of 2 cubes? Nope. Let's put a parentheses around it. Same thing for v minus 1. All 3 questions are no. Now for our final trinomial. Write down your 2 parentheses. V squared splits into v times v. What 2 numbers could multiply to a +20 that will add and give me 12? 2 and 10. When 2 numbers multiply to a positive and they add, they're going to have the same signs, and they will always be the same as the middle term. Now it's time to state our excluded values. Each of these denominators will give us an excluded value. The first will be that v cannot equal 3, and the second will be that v cannot equal 1. It's time to turn this into a multiplication problem and to use our reciprocal. The v plus 2 and v plus 10 will come to the denominator, and the v minus 1 will go to the numerator. Once you do this, I want you to check for any new excluded values. This problem actually does have new excluded values. The excluded value for this first parentheses will be that v cannot equal -2. And the excluded value for this final parentheses will be v cannot equal -10. These are the numbers that would result in a 0 in the denominator, and then the fraction would be undefined. Now it's time to cancel anything in the numerator with anything in the denominator. I can cancel the v minus 3 with the v minus 3, and the v plus 2 with the v plus 2. The only things that remain are the v minus 1 in the numerator and the v plus 10 in the denominator. You have an option of writing them with or without parentheses. If you choose without parentheses, please remember the v's cannot cancel. They're part of a set. Binomials can only cancel if you have another identical binomial. All right, it's time for our final example. And in this example, I have some trinomials where the lead coefficient remains. Let's start with these binomials. What do these 2 terms have in common? They're both divisible by 3. I'll write down what they have in common and then divide it out of each term. The parentheses will hold what is left over. (12 minus 9x). What do these 2 terms have in common? They are also divisible by 3. When I divide 3 into each of these terms, I'm left with 4 minus 3x. Now I have a trinomial. Do these 3 terms have something in common? No, so I can't get rid of any of these numbers or reduce them. I have to deal with this lead coefficient. There's several ways to do this. One method is to take your lead and multiply it times your last to get the number that you're going to factor. I'm going to go ahead and write down my 2 parentheses. The x squared breaks down into x times x. And I'm trying to think of two numbers that could multiply to a negative 15 that when I subtract them will give me negative 14. They are going to have opposite signs. Have you thought of what they are? 1 and 15. Opposite signs subtract, and they keep the sign of the larger term. That's why the larger term will match the middle number. Negative 15 and positive 1. Now we're not done. Because we had this lead coefficient, not only do we have to multiply it in the first step, but we have to divide it in the last step. If it doesn't divide evenly, I want you to bring that number to the front. This factor will be 5x plus 1. If it does divide evenly, I want you to go ahead and do it. X minus 3. Like I said, this is only one method. If this one doesn't work for you, there's several others out there. I'm going to use that same method to factor this trinomial below. They don't have something in common, so I'm going to multiply my first term times my last term, and that gives me 12. The x squared breaks down into x times x. I need to think of two numbers that can multiply to a positive 12 that when I add them together will give me a 7. 3 and 4. Anytime they multiply to a positive and they add, we're going to have the same signs, and they will both have the same sign as the middle term. Now remember, we're not done. Since we multiplied by the lead, we are also going to divide by the lead. If it does divide evenly, go ahead and do that. If it does not divide evenly, bring that to the front. Now it's time to look for our excluded values. We're going to look at everything across the denominator. Remember, constants don't have excluded values, so I don't have to worry about this number. 4 minus 3x. If I set that not equal to 0, and I go through the process of solving, subtracting 4, and then dividing by negative 3, I will find that x is not equal to 4/3. X minus 1. When I solve this, I learned that x is not equal to 1. 3x minus 4 is going to result in the same excluded value as the 4 minus 3x. So I don't need to go through that process again. Now it's time to change this to a multiplication problem and to use our reciprocal. My new fraction, everything in the numerator will come to the denominator. And everything in the denominator will come to the numerator. When you create this new fraction, your reciprocal, I want you to double check those excluded values one more time. We actually have two new excluded values. This first parentheses, when I solve it, is going to give me an excluded value of negative 1/5. And the second parentheses will give me my final excluded value of positive 3. Now it's time to cancel. Things that I can see that cancel. The 3 is pretty automatic. So is the 5x plus 1. And then I get down to this part right here. It looks like I don't have anything else to cancel. Let me write out what's left. On top, I've got x minus 1, and I have 3x minus 4. In the denominator, I have 4 minus 3x, and I have x minus 3. So yesterday we learned a trick. If you have two parentheses that have exactly the same numbers, but you notice that their signs are exactly the opposites, a positive 3x and a negative 3x, a -4, and a +4. You can fix this. We learned that you could pull out a -1. You're basically just going to divide out this -1, and it's going to change the sign of both of these terms. So where do you put that -1? You've got a couple options. It's only being pulled out of this one parentheses, so you could put another parentheses in the middle with a -1, but I think the easiest thing to do is to pull it all the way out here to the front. We know that multiplication property tells us that if we have three things that are multiplied together, the order of those multiplied numbers or variables doesn't matter. So I can pull it all the way out here to the front. It will then change this term to a -3x and this one to a +4, which means I can cancel these two parentheses. So my final answer is going to be -1 times x minus 1 over x minus 3.